Well, welcome to our OCS Teach video series. My name is Les Folland.
My name is John Green.
And this morning we're looking at how to construct a line graph. John, in science and maths we do this sort of thing pretty regularly from year 5 all the way up to year 12. It's about analysing and processing data.
Yeah.
And one place we get data from is when we do scientific experiments. So John, over here, students conducted an experiment. They've heated up a beaker of water for 6 minutes and taken the temperature every minute. Now have a look at that table of numbers there, John. What can you make of it? What does it tell you already?
Well, what I feel is that for each minute the temperature starts low and it's getting hotter as we go along. It ends at 73 degrees.
Okay, so you get information from numbers, but when we actually graph them out, it gives us a visual display of the whole thing. And often we can see things, trends and correlations that we can't see just in the numbers.
Yeah.
So that's why this is a pretty important skill.
I feel like you've got this ready from before.
Yes, I have. Straight out of the oven. John, I've already put some things here that really are important in a good line graph. One of them is putting a heading. I've had some students call it their graph my graph. This heading is better than that. What do you think?
I feel like it's better because it tells us we're looking at water temperature and we're looking at what's happening to the water.
Excellent.
That increases the temperature.
So it informs you, looking at this graph, what it's about.
Yep.
Okay. So when we're drawing our line graph, we begin by putting axes using a ruler and a pencil, and we place it low on our page. Here's our page, but with enough room to put the information, the scale and the label. And when we put our labels, what else do you notice here, John?
Well, the labels have the units of measurement with them, and the labels tell us exactly what is happening on each axis. And the unit of measurement relates to the label, so minutes and degrees Celsius.
Excellent, excellent. Because if we just had 3, we don't know whether that's 3 hours, 3 days.
Could be anything.
Could be anything. So the
Can I ask a question, Les?
Sure.
You've got 2 little lines here.
Well, sometimes when we have our scale like this, we start at 0 and we go upwards.
Yep.
Sometimes though, nothing's happening between 0 and our first number. We start at 24.
Yep.
So that'd be wasted space. So when we start our axis at a number that's not 0, we just put a couple of little lines there to indicate that we're leaving out those numbers and we're putting our scale on there. Now, 2 things about the scale, John. Classic errors are made when it comes to putting these numbers here. What do you notice here about these numbers compared to the numbers there?
Well, I feel like you didn't start on the right number, Les. You didn't start on 24.
That's right. A lot of students' instinct is put the first number 24, second number 32, next number 41. The problem with that is these numbers aren't meant to be those numbers.
Oh.
They're meant to be the value of the temperature evenly spaced. Really important, consistently spaced. So 20 to 30, if that's 10 degrees, that same distance has to be 10 degrees all the way up the scale.
Scale stays the same.
Scale stays the same. We've done the same with minutes over here.
Yep.
The reason for that is the line that we're going to get with our data only is meaningful if there's a consistency in the scale here. So let's put our numbers on there, John.
Alright, well, at 0 we have 24.
So 0 minutes we go up to 24. And look what I'm doing, I'm putting a small x. Let's keep going.
Alright, at 1 minute we have 32 degrees.
1 minute we go up to 32. Good.
At 2 minutes we go 41 degrees. At 3 minutes we go 47 degrees. At 4 minutes we go 56 degrees. At 5 minutes we go 65 degrees. And at 6 minutes we go 73 degrees.
Now for our data points, what I haven't done is put a big blob. Some of our students will put a really big dot for their data point. That's not much use because you don't know exactly where the data point is. A small x allows you to place very exactly the cross.
It's where they cross.
That's where they cross is where the line is. Excellent. So now we've mapped our data points on there. The last thing we're going to do is draw our line of best fit. Often students are tempted just to draw lines joining each dot, wherever it happens to be, each data point.
Yep.
That's almost never the right approach because the way the dots are, there's a clear trend. So our better option is to draw ourselves a line that starts at the beginning and the end of the data and goes straight through the middle. I'm just going to drop that a little bit there, John. Straight through the middle of our data, all the way up.
Correct.
The line of best fit gives us an indication of the temperatures changing over time.
Okay. Now I see you've gone past that last data point.
Well, one reason is if we kept heating it, what would we expect to happen?
The temperature would go
This
up.
actually allows us to predict where this temperature is going. So the key things for making a good line graph, John. First one was?
Great heading, title that gives you information about what you're going to be looking at in your graph.
Excellent. The second one
You
was?
start in the lower corner, leaving space for information about what is on your axes.
Excellent. Third one was?
Labeling your axes, not just with what they're looking at, but also the unit of measurement that's going to be on there, minutes and degrees Celsius.
Excellent. And then the fourth one was?
Our scale. We start at 0, then we go across, and if we don't start at 0, we start the number and we go evenly up the whole way so that our numbers are evenly spaced the whole way up.
Excellent. Fifth one was?
Fifth one was that we put our data points on as accurately as we can. We don't put big dots, we put a nice neat little cross where that data point is.
Excellent. And then the sixth one, John?
Our line of best fit. Here we make sure we're getting our line, not going from cross to cross, but actually going in between, fitting the data points the best we can.
Excellent. The line of best fit. So that's how you do a really good line graph, whether it's in year 5 all the way through to year 12. Hey, thanks for joining us for our OCS Teach video series.
Have a great day.